Hello everyone. So this is the new topic, that is uniform accelerations motion. We have completed the uniform velocity motions. And what is the difference between the uniform acceleration? See, if I'm talking about the accelerations, A is equal to dv upon dt. We all know that. Simply, okay? If this is constant, so what would be the velocity? It would be at plus c. So acceleration is also constant. Uniform is constant. So we can say that the velocity is linear. You can say it depends on the time. So this would be linear. And we have seen that the velocity is linear because of acceleration is constant. So if I'm drawing the curve of displacement, velocity and accelerations, you will be able to see the difference. Okay. But first, let me tell you one thing. If this is a stroke of the follower, this is the initial and this is the final point. Okay. And this is the center point. So this is completely stroke which is s. If this is the stroke s, that would be s by 2. That would be s by 2. We all know that. So time taken to cover the stroke s is, if it is t, so what would be the time taken for this? It would be t naught by 2. Is that okay? It would be t naught by 2. If I'm talking about the outstroke angles. So what would be the time if the stroke is s by 2? Let us consider that s by 2 is equal to 0 plus half a t square. What is t? T is t naught by 2. And what is t naught? T naught is theta naught upon omega. Theta naught upon omega. Okay, so that is theta naught upon 2 omega. Because I'm talking about the t naught by 2 whole square. Okay, so finally you will get s is equal to what? That is, what you will get? A theta naught square upon 4 omega square, from where you will get the value of accelerations, that comes out to be 4 omega square s 4 omega square s upon theta naught square. Clear? Is that clear? This is the uniform acceleration. Uniform accelerations, where s denotes the stroke. Okay, if you want to find out the v maximum, why we are going to calculate the v maximum? See, v maximum means, see, if this is a uniform acceleration, the velocity will increase up to the maximum. This is v naught maximum conditions, and again it will decrease up to this final point. Okay, and become 0. So this is the conditions where v naught is maximum. Okay, so we have considered uniform accelerations from initial condition to the maximum. Okay, after maximum it will start decreasing. That means that would be uniform retardation. Okay, so there will be a uniform retardation uniform retardation motion, and this would be the uniform acceleration motion. This would be uniform acceleration motion. Is that okay? So what would be the v naught maximum? It would be, you can say that that would be u plus at. U is the initial velocity, which is 0, plus acceleration is 4 omega square s upon theta naught square, multiply, what is the time? Time is theta naught upon 2 omega. 2 omega in case of uniform accelerations, because we are going to consider the time up to the maximum velocity, because after that there will be retardations. Okay, So from initial conditions where v is equal to 0, where v is equal to 0 up to the center point which is having the maximum velocity, okay, because this is a uniform accelerations motion, okay. So from 0 to maximum there will be uniform acceleration, and from maximum to again 0 there will be uniform retardation, okay. So from here you will get the value of maximum velocity, that would be v naught maximum 2 omega s upon theta naught, and that would be known as 2 v naught. This is v maximum, okay. We are going to calculate v maximum here, maximum velocity, and it would be 2 v naught maximum. Is that okay? So what is the v maximum? Whether it is out stroke or the return stroke, it would be twice of v naught maximum, okay. And the applications where we use the uniform accelerations motions would be slightly better, and remember that this is used at low speed, okay. So what is the physical applications that is used at low speed applications? Use at low speed, we use uniform accelerations motion, okay. And the second point that you must remember that this is slightly better than, this is slightly better than uniform velocity rotation, okay. So this is slightly better than uniform velocity motions, that's why we use it at low speed. So I hope you will understand these solutions, okay. So thank you.